Swayam Prabha. Digital India. Educated India.
Welcome to the fourth lecture of the lecture series on tutorials on design of transmission elements. And this lecture is on tutorial on basics and force analysis of the bevel gear. This is a third type of gear which we are going to take. And this gear is used to transmit power between two shafts which are intersecting with each other, and the angle between the shaft may be equal to 90 degree, more than 90 degree or less than 90 degree. But in this problem, the problem which we are going to take, the shaft angle will be 90 degree. So first of all, we will study some basics and then we will take a problem and solve it to get the different parameters of the bevel gear which are used in its nomenclature, and will do the force analysis to get the forces which are transmitted from driving gear to the driven gear, driving bevel gear to the driven bevel gear, and the forces which are applied by the driving gear on the driven gear and driven gear on the driving gear. And thereafter we will find the bearing reactions. That means the shaft on which the gears were mounted, those shafts will be supported by bearings, and when the power will be transmitted, those bearings have to support the load which are transferred. So let us take first some basics of the bevel gear. As visible, the bevel gears are formed on a cone, whereas the two gears which we studied in our previous classes, the spur gear and helical gear, they were used to transmit power between two parallel shafts like this, and the gears will be mounted like this in both the cases. But in the case of this bevel gear, the shaft, if this is the shaft of the pinion, this is the shaft of the gear, then they are making some angle, they are intersecting, and the angle between the shaft is this. Now, in the case of spur and bevel gear, there were pitch cylinders and correspondingly there were pitch circles like this. Whereas in the case of bevel gear, the pitch cones will be there, and those pitch cones will be represented by like this. This is the axis of rotation of one of the gear, and this is the axis of rotation of the another. So in the case of spur and helical gear, there were pitch cylinders, but now in the case of bevel gear, there will be pitch cone, and they will be intersecting at point which is called the apex of pitch cones and intersection of shaft. Now, when you will see the bevel gear, then the gear tooth will not be uniform throughout the width. when you will see it from this end, the size of the gear tooth will look bigger, whereas when you will see from this side, then it will be smaller. And so, the top land of the bevel gear will not be just a rectangle as where in the case of spur and helical gear. In this case, it will be from the big end, it will have a bigger length, and at the small end, it will have a small thickness. And so, this will be the way the top land of bevel gear will look like. So, the bevel gear is defined from its big end. Let us see the other nomenclatures. In the case of bevel gear, it is shown a sectional view. So, the pitch cone is this one. A sectional view of bevel gear is shown in this figure, where this is the pitch cone. If you will see, this is the pitch cone, and correspondingly different nomenclatures are there. This is the big end of the gear tooth. This is the big end of the gear tooth, and this one is the small end and the big end. And when these two lines are extended, they also meet at the apex of the pitch cone. So, the different angles are there. The angle between the axis of the shaft and this pitch line, red line, is called the pitch angle. Pitch angle represented by gamma. And these are important parameters which will be used in our problem. This is the cone length. So, pitch angle, cone distance, the addendum and dedendums will be measured from the big end. This is the big end. So, this is the addendum of the gear tooth and this is dedendum. And the pitch diameter is defined from the big end, and so this diameter is the pitch diameter of the bevel gear. Well, now let us take a problem. In this problem, a bevel gear pinion rotates at 600 rpm in the direction shown. This is the pinion, the pitch cone of the pinion is shown. This is the pitch cone of the pinion. And it is rotating in the direction like this. And this is the direction that when you will view the pinion from the positive x axis, then it is rotating in a clockwise direction. So, and transmits 3.75 kilowatt to the gear. The mounting distances, the location of all bearings and the average pitch radii of pinion and gear are shown in the figure. That means from the big end when you will see the pinion, then this is the pitch diameter of the pinion. Similarly, the pitch diameter of the gear will be from its big end. This is the pitch cone of the gear, and so from its big end, this one will be the pitch diameter of the gear, and that is 2 to 5 mm, 225 mm. The face width, this is the face width. So, face width of the gears, either pinion and gear, is given, and that is 60 mm. The pitch angle of the gear will be the angle between axis of the rotation of the gear and the pitch cone, this. So, this angle is gamma pitch cone angle of the gear. Similarly, pitch cone angle of the pinion will be the angle between axis of rotation of the pinion and the pitch cone of the pinion. That means this one, and it is shown here as gamma p. Well, now the shaft of the gear is supported by bearing D and bearing C, and shaft of the pinion is supported on bearing A and bearing B. The number of tooth on the pinion is given as 15, and the module of both the gears will be 4 mm, and number of teeth on the gear is 45. Now, we have to find bearing forces on the gear shaft. This is the gear shaft. So, CD is the gear shaft, and on the gear shaft we have to find the bearing reactions. Now, the given are number of revolution of the pinion 600 rpm, the power which you have to transmit H is 3.75 kilowatt, and pitch circle diameter of the pinion 75, pitch circle diameter of the gear 225 mm, face width is 60 mm, and the average pitch diameter of the pinion. One information is also given here, and that is very important in determination of pitch line velocity and transmitted load. That is the average diameter of the pinion and gear, because we know that the bevel gear is in the form of cone, and so the pitch cone diameter will vary when we will move from this end to this end in this way. Here the diameter is this one at the big end, and the small end diameter is this one. So, which diameter we should take to calculate the pitch line velocity V, which is pi pitch circle diameter and the RPS, rotation in second, divided by 1000, because D is taken in mm and this will come in meter per second. This N is RPS, revolution per second. Now, which diameter we should take? If we take this big end diameter, which is the pitch diameter of the bevel gear, then this V will come high, and when we will take the pitch diameter corresponding to a small end, then it will come smaller. So, what we do is we take the average diameter of the pinion to calculate the pitch line velocity. So, this D will be actually D average, and we have to find the average of the pinion. So, if we know the face width and we know the pitch circle diameter of the bevel gear, which is D, and that is measured from the big end, then knowing this pitch cone angle gamma, this angle is gamma, we can find the average pitch diameter. But here the average pitch diameters are given. This distance is given, and this is the average pitch diameter or average pitch radius, you say. This is showing the radius. This distance is given, this, and this is 32. This is equal to this one. So, this is your 32. It means pitch circle radius, average pitch radius is 32 for the case of pinion. So, D average will be 2 times 32 for the case of pinion. It is given in this figure. Similarly, for the case of see this distance. This distance is given as 96, and this is the distance equal to this one, and that is D average divided by 2 of the gear, and that is given as 96. So, average pitch diameter of the pinion, D average pinion, is equal to 32 multiplied by 2. The figure is shown in more detail here. Now, in this figure, 2 bevel gears in section are shown, which are messing with each other. This is the gear and this is the pinion, and the pitch diameter of the gear is measured from its big end along the pitch cone. This is the pitch cone. This one is the pitch cone of the gear, and pitch cone of the pinion is this one. Well, this and this. So, pitch circle diameter of the pinion is dg, gear is dg, and the pinion is from the pitch cone, this is dp, and the pitch circle, your pitch cone angle or the simple pitch angle of the gear is gamma g, and pitch angle of the pinion is this one, gamma p. So, now we can find the cone distance, which is distance O to C is the cone distance. Knowing that the angle between the shaft of pinion and gear is 90 degree, the pitch cone is equal to OC or OB, and OA is equal to DG divided by 2. OA, this OA is equal to this half distance, this one, and so it will be DP divided by 2. OA is DP divided by 2. Similarly, AB is half of the pitch diameter of the gear, and so it is DG divided by 2. So, OAB is a right angle triangle, and so we can find the OB knowing the value of OA and AB, that is given here. Now, using this triangle we can find the pitch angle of the gear, and that is tan of the gamma g is equal to AB divided by OA. AB is dg divided by 2 and OA is dp divided by 2. And so, tan gamma g is dg divided by dp, and so gamma g, pitch angle of the gear, is equal to tan inverse dg divided by dp, or using the module we can find it as tan inverse number of teeth on the gear divided by number of teeth on the pinion. Similarly, we can find the pitch angle for the pinion using this triangle, and in this right angle triangle this tan of the gamma p will equal to this distance, which is dp divided by 2, and this distance which is dg divided by 2. And so, gamma p of the pitch angle of the pinion is tan inverse zp divided by zg. Now, in our case we know that dp is 75, pitch circle diameter of the pinion is 75 mm, and pitch circle diameter of the gear is 225. And so, pitch angle of the pinion is tan inverse 75 divided by 225, that is 18.35 degree, and gamma g is equal to tan inverse pitch circle diameter of the gear divided by pitch circle diameter of the pinion, that is 71.65. In this figure, a bevel gear is shown and the forces which are acting on it are shown in terms of an element A, B, C, D, E, F, G and H, and the DC is the tangential direction. This is the tangential direction, and HC is the radial direction, and GC is the axial direction. It is along the axis of rotation of the bevel gear. So, this one is the axial direction, and the normal direction, the force is acting from the mating gear in the direction of AC, and that is the normal load Wn, and the angle between the tangential direction and the normal direction is the pressure angle alpha. So, in terms of Wn, we can find the transmitted load which is acting in the direction of D to C, and that is the Wt. So, Wt will be Wn cos of the phi, Wn cos of the phi. Similarly, the component of Wn in the direction of BC is the separating force Ws, and that will be given by Wn sine of the phi. Now, this Wt can also be obtained knowing the average pitch circle radius of the bevel gear and RPS of the bevel gear. So, let us find first the pitch line velocity corresponding to the average pitch radius. This is 2 pi r average of the pinion and the RPS divided by 1000. We are dividing it by 1000 because the average pitch circle radius given in the problem is 32 mm. To convert it into meter, we are dividing it by 1000. So, substituting the average pitch circle radius of the bevel gear as 32 and RPS of this is 10, we got the pitch line velocity as 2.011 meter per second. Therefore, the transmitted load is, this transmitted load is the power which you want to transmit divided by pitch line velocity. Substituting the power, it is given in the problem as 3.75 kilowatt, and substituting this we got Wt as 1.865. Now, we know that Wt is equal to Wn cos of the phi, and so Wn is equal to Wt divided by cos phi. So, Wn is Wt divided by cos phi, and Wr, the radial force, will be obtained by taking the component of Ws in the direction of Hc, and the angle between this AD and ED is equal to gamma. So, ED is parallel to this HC. So, angle between BC and HC is gamma. So, we can find Wr in terms of this Ws, Ws cos of the gamma, Ws cos of the gamma will be Wr, and Ws is Wn cos sine of the phi. So, Wn sine of the phi and cos of the gamma. Okay. So, substituting Wn in terms of Wt, we got Wr in terms of Wt tan phi cos gamma, and the axial load similarly can be obtained as Ws sine of the gamma, which is equal to Wt tan of the phi and sine of the gamma. Now, from above equations, with gamma of the gear and gamma of the pinion as 71.65, this one, and gamma p as 18.35 degree, we got Wr, substituting all the values, known values, it is 214.7 Newton. Similarly, the axial load, after substituting the value of Wt, which is obtained here, and substituting the value of phi, which is given in our problem, and as a 20 degree, and the gamma g as this one, we get the Wa as 644.28 Newton. So, let us find the direction of transmitted load Wtg. This is the gear mesh given in our problem, and this is the free body diagram of the shaft of the gear DC. The coordinate system is taken in such a way that this apex is the origin of the coordinate system, and the axis of the pinion, along the axis of the pinion is x axis, and along this apex to the bearing D is the y axis, and perpendicular to the screen is z axis. So, the free body diagram of the gear shaft is shown here. This is D, C, this is your shaft DC, shaft of the gear, and this is y axis, and the apex is shown here. This is the apex, and so the origin of the coordinate system. This is your x axis, and x axis is the direction of axis of rotation of the pinion. So, this is direction of rotation of the pinion or the axis of the pinion. This is axis of the gear, and this one is taken as the z axis. Z axis in this figure was perpendicular to the screen. Now, it is shown here. This is the origin. So, in this isometric view, the shaft of the gear is shown, and the bearings D and C are shown, and the pitch point, which is somewhere here, this is the pitch point, which is called the G, and this pitch point will be at a distance of this 96, the average distance. So, from the origin, this distance, pitch point, where the forces will act, the transmitted force, axial force and radial force will act, this will be at a distance of 96 in the direction of x from the y axis. So, from the y axis, from the origin at a distance of 32, from the origin at a distance of 32, we will move in the direction of x, a distance equal to 96, we will get the G point, where this is the G point. So, this is the G point. And from the y axis, this G point is at a distance of 96, and from the origin, this point is at a distance of this 32, and this one is this distance. So, this is the isometric view. Now, Wt on the gear, Wt on the pinion was obtained as 1.865 kilonewton, and it will be same for the case of gear. So, Wt on the gear is also equal to 1.865 kilonewton. Now, pinion is rotating in clockwise direction when viewed from the positive axis. This pinion is rotating in a clockwise direction when viewed from the positive x-axis. As pinion is a driving member, this pinion is a driving member, and so the transmitted force on this pinion will act in the direction opposite to its direction of rotation. It is shown in this figure. This is the pitch circle when we will view this pitch cone from the big end, and so the diameter of this will equal to pitch circle diameter of the pinion. Okay. The axis is, this is z axis. When you will view from this direction, then the axis which was z axis, which is perpendicular to the screen, will become this one. This is the z, and the y axis is this one. When you will view the pinion from this end, the big end will look like this of the pinion. Big end of the pinion will look like this circle, and its diameter will be dp, and it is rotating in a clockwise direction, well, when viewed from the positive x-axis. And so, as it is a driving member, so the transmitted load on this pinion will act in this direction, opposite to the direction of rotation, and that will be in the negative z axis. This will be in the negative z direction. Now, the gear is a driven member, and so the Wt on the gear will act opposite to this Wt of the pinion. So, Wt gear will be opposite to the Wt of the pinion. So, Wtg will act in this direction, and this is the direction of positive z, positive z. It means the transmitted load on the gear will act in the positive z direction. This is shown here. This is your z direction, and so Wt on the gear will act in the positive z direction. Now, let us find the direction of radial force Wrg on the gear. Wrg, the magnitude was determined as 214.7 Newton. Now, the radial force acts along the axis of rotation. Therefore, radial force on the gear Wrg will act in the negative x direction. The radial force, you see, always acts along the axis of rotation. So, radial force on the pinion will act in this direction. This will be Wr of the pinion, and Wr of the gear will act from this G point, the pitch point. It will act along the axis of rotation of the gear. So, this is your Wr gear. So, Wr gear will act in the negative x direction. Well, this is the direction of radial force. This is your direction of radial force in the negative x direction. This is your x direction. So, W R G will act in this direction at G point. Similarly, radial force on the pinion will act along the positive y direction. Direction of the radial force of the pinion is this one. Now, the axial force. Axial force, the magnitude was determined as 6.44.28 Newton. Now, the radial force on the pinion will act along the positive y axis. Radial force on the pinion was acting in the positive y direction, just we have determined. This is the direction of the radial force on pinion. This is the radial force on the pinion. This is W R of the pinion, and this is acting in the positive y direction, and this direction is the direction of the axial direction of the gear. This direction means y direction is the direction of axis of the gear. So, the axial force on the gear will act in the direction of y. So, the reaction of this WRP will be in this way. This is the reaction of WRP, and the reaction will act on the gear. So, this is the force which will act on the gear applied by the pinion, and this force is acting in the axial direction, and so this force will be your W axial for the case of gear. So, this is giving you the direction of the axial force on the gear, and that will be opposite to the direction of radial force on the pinion. Axial force on gear will act opposite to the radial force on pinion. This is shown here. Therefore, axial force on the gear will act in the negative y direction, this one. That means, on the pitch point G, when pinion is transmitting power to the gear, the forces which are acting at pitch point G are WTG in the positive z direction, WRG acting in the negative x direction, and WAG which is acting in the negative y direction. Now, we can start the force analysis for the shaft of the gear. This is the free body diagram with the reactions on the bearing. This is the bearing D on the shaft of the gear, and the reactions are taken in the direction of x and direction of z. Reaction is not taken along the y direction, because among this C and D, one of the bearing will take the axial load or the thrust load, and that bearing is taken as C. So, on the C, we will have axial component, axial reaction, that is FCY, and along the Z reaction is FCZ, and along the x axis the reaction is FCX. On the D bearing, reactions only in the directions of x and z are taken. Along the y, which is the axial direction of the gear, is not taken, because this will not take the axial load or this will not take the thrust load. Thrust load will be taken by C. Any one of the bearing is taken to support the axial load. So, this is the free body diagram. Now, what we will do is, we will apply the static equilibrium equations to determine these unknown reactions and this torque. We have 1, 2, 3, 4, 5, 6 unknowns, and static equilibrium equations are summation of forces in the direction of x is equal to 0, summation of forces in the direction of y is equal to 0, summation of forces in the direction of z is equal to 0, and the movements along the x, y, and z is equal to 0. So, we have 6 equations and we can find the unknowns. But when we view the forces which are acting in this figure, then along the y direction only 2 forces are acting. Along the y direction WAP is WAG is acting, and on the bearing C FCY is acting. So, FCY will equal to this WAG, which is 644.28, that is determined here. In this figure, the Free-body diagram of the bevel gear in mesh is given. This G is the pitch point, and C and D are the bearings, where reactionary forces Fc, vector Fc and vector Fd is acting. So, in preparing to make a sum of the moments about bearing D, defining the position vector from D to G as D to G, we take the position vector, and that position vector Rg, this one, this is the Rg position vector, is given by 96I, because the x direction is this one and the distance from y axis to the point G is 96 along the positive x direction. So, 96I, and this G is from this, it is along this direction, and the distance is 60 plus 32 along the y direction. So, 60 plus 32J. So, Rg vector, this dg, is 90I minus 92J. We shall also require a vector from D to C, and this vector Rc is minus 60 plus 90 J along the y direction, and so J, it is minus 150 J. Then summing moments about D gives Rg cross W, Rg cross the W vector plus Rc position vector, this is the Rc position vector cross the force vector at C, which is Fc, plus the torque along the y axis, and this Fc is actually, Fc vector is equal to, along the x direction the force is the component of force is Fcx, so I, and along the y direction the force is acting along the positive y axis, so plus Fc yj, and along the z direction the component of Fc force is acting along the negative y axis, so minus Fc z k. Okay. So, this is your Fc vector. So, substituting the values, we have this one, this is your Fc vector, this one, this is your W vector, this is your W vector, these are Fc vector. Now, we will do the cross product of these two vectors and cross product of these two vectors and compare the I terms, j terms and k terms separately, and thus we will have, after taking the cross products, we have this I, and I is somewhere here, and so this I and this I will be compared. It means minus 150 Fc z and minus this I, and minus 17158 I is equal to 0, and so this I and I will be cancelled. We will have FCZ is equal to minus 17158 divided by minus of the 150. Minus and minus will be cancelled. We will get it as, let us see, FCZ is equal to this one. It has, yes. When we will take it here, it will become positive and it will be negative, and so it will be minus this minus 1143.9 Newton. And similarly, comparing the this term, K term, K and K term, we will get the FCK. This is FCX. FCX is determined. And comparing the J term, this J term and this J term, we will get the T vector, and the T vector, the torque is 167.85 Newton meter. Now, sum the forces to 0. That means all the forces, summation of all forces should be 0. The FD vector, FC vector and the W vector will be 0. And substituting all these vectors, we have substituted the vectors and simplifying and comparing again the similar I terms, J terms and K terms separately, we get FCY is 644 Newton, and therefore, the total force which is acting at C is equal to, along the X is 518.1 Newton. So, this FCX, this is actually the FCX. This is the J component is FCY and the K component is FCZ. So, we got all the reactionary forces at the bearing C. Similarly, the reactionary forces at D is along the X is this one. So, it is FDX, and along the along the Z is this K and Newton, this is your FDZ. Okay. So, we got the reactionary forces at D also. So, these are all shown in this figure B, the all forces. Now, after completing the this problem and determining different parameters of the bevel gear, we determined the pitch angles of the pinion and gear. Thereafter, we determined the pitch line velocity, and knowing the pitch line velocity and knowing the power which we want to transmit, we determined the transmitted load, and after getting the transmitted load, we found the axial component and the radial component which will act at the pitch point. Thereafter, we found the direction of these forces which acts on the pitch point capital G. Those forces were on the gear shaft, the W transmitted on the gear WTG, then WAG, axial force on the gear, and the radial force on the gear which is WRG. Now, knowing the force components at the pitch point, we found the reaction at the support. That means the bearing which supported the gear shaft, on that bearing reactions were determined, and the torque which is transmitted from pinion to gear or the torque which acts on the gear shaft was determined. Now, next we will go for the design methodology of the bevel gear, And for the design methodology, we must know what type of stresses acts on the gear, pinion gear or the bevel gear. So, those stresses are again the bending stresses and the surface stresses. Bending stresses acts at the root of the gear tooth, and the contact stress acts at the point of contact when the mating gear tooth comes in contact with the gear in mesh or the gear tooth. The stresses are the bending stress and the contact stress. So, the failure mode will be fatigue failure due to fluctuating bending stresses at the root of the tooth, surface fatigue of the tooth surfaces. Then we have to determine the bending fatigue stress, then the surface and the surface fatigue stress, and thereafter bending fatigue strength. Under bending, what is the strength of the material, and then under contact stresses, what is the strength of the material. So, against contact stresses, what is the strength, and against bending stresses, what is the strength of the material, that we must know. So, knowing the bending fatigue stress, surface fatigue stress, then the bending fatigue strength and the contact fatigue strength, we can find the factor of safety. But the problem is the bending fatigue stress has different factors taking care of the actual situation of the transmission of the power, and correspondingly we have to do the analysis in this way. We must determine the geometrical parameters of the gear, and then we should do the force analysis to get the transmitted force, axial force and the radial force on the gear, and then the strength analysis. So, from the force analysis, we will know the stresses which will act on the gear tooth, and from the strength analysis, we will find the strength of the material of the gear and pinion under bending and contact stresses. So, these are the geometrical parameters. That means, we must know the pitch circle diameter of the pinion, pitch circle diameter of the gear, and that will be ZG multiplied by the module. This module is corresponding to big end of the gear, big end. Then we must know pitch cone angle of the gear and pitch cone angle of the pinion. Then knowing all these, this and these parameters, we will find the radial force, axial force and the transmitted force. So, transmitted force is equal to simply H divided by phi, the power which we want to transmit divided by your pitch line velocity. Then these are the strengths. The surface fatigue strength is determined from the AGMA, American Gear Manufacturers Association data. This again we get from this, and this is based on 10 to the power 7 number of life, and reliability equal to 99% and temperature less than 120 degrees centigrade. So, if the condition in which our gear has to work is other than this, then we have to multiply it by different factors. So, let us see, the AGMA bending stress is given by this equation, where this WT is the transmitted load based on the large end of the tooth or the average pitch diameter. Then this is the module, this is the face width, this is your geometry factor, this one is the velocity factor or the dynamic factor, overload factor, mounting factor, the size factor and the lengthwise curvature factor. Thereafter, the AGMA bending strength equation is given by SFB, this one. This is the temperature factor. If your gear has to work other temperature more than 120 degrees centigrade, then this temperature factor will come into picture. this life factor, if life is other than 10 to the power 7 number of cycle, then this will come into picture. If reliability is other than 99%, then this will come into picture. This is the bending fatigue strength at 10 to the power 9 cycles and 99% reliability and room temperature. Then bending fatigue factor of safety is the strength divided by the bending stress. Similarly, for the surface stresses, this is the equation, and these are the different factors which will be used, and the surface fatigue strength is determined from this one, with the life factor, hardness ratio factor will be used only for the gear, not for the pinion, and reliability factor and the temperature factor, and the correspondingly the factor of safety against surface fatigue will be SFC, this SFC divided by the surface contact stress. So, with this we completed the basics and force analysis of the bevel gear, and in the next class we will take the design problem related to the bevel gear. Thank you.
Hello, I am Professor A.K. Sharma and I teach sociology in IIT Kanpur. I am taking up a question, what is world population crisis? World population crisis refers to explosive growth of population which occurred during 1950s and 1960s. For millions of years, some people estimate that perhaps man appeared on this planet Earth 5 lakhs years ago. It took these 5 lakhs years for world population to reach first billion in 1820 AD, and that means that the population in ancient times must have been rising at rate 0.000 something % per year. Now, in 1950s and 1960s in the world, you find that population started growing at rate more than 2% per year. This is what is meant by population crisis. You can imagine that if a population grows or anything grows at 2% per year, then in about 35 years time it can double. And obviously, particularly in the context of less developed countries, it had implications for poverty removal, for employment generation, for maintaining health, improving life expectancy, raising educational levels, etc., etc. The reason behind this population crisis was improvement in life expectancy or improvement in general health standards of populations. You may not be knowing, or you will be surprised to know that about 100 years ago in our country, life expectancy means average age of death or average age of life, whatever you say, of a newly born child was only 20 years, and today it has reached the level of 68 years. Much of this improvement in less developed countries occurred in 1950s and 60s, and therefore, with improvement in health, improvement in life expectancy or average age of birth, average age of death, and population started growing at explosive rates, and people started writing about this. This is population explosion, or this is population crisis. And now one can say that the period of peak growth rate is over, and from 1971 onwards, in the world as well as in our country, growth rate of population has started declining. Now, in India, you may like to know what is the current growth rate of India's population. Currently, India's population is growing at 1.5% per year, and the reason is that after sudden or unexpected improvement in health conditions in 50s and 60s, which led to population crisis, we find that today average number of children has also started coming down. So, there was a time when average number of children per woman was around 11 or 12, now it has come down to 2.5, and therefore, the growth rate of India's population has come down to 1.5%, and we can hope that in the future, means in the coming decades, even if nothing changes on the front of fertility or number of children, India's growth rate of population will decrease further and eventually come to a 0 level, as said by the 11th 5-year plan of India. And now, the major cause of high growth rate of population is not high fertility, but the age distribution of population. So, we have a high percentage of population at the younger ages, and that is the cause of high rate of growth of population. Eventually, when population of India will also age like population of other developed countries, our growth rate will start falling. Thank you. Now, we will meet in the future.